We're going to start with our regular warm-up. All right, so I'm going to give you folks a couple minutes. And remember, you're trying to come up with at least 2 ways to solve it. If teachers are new to the field or they're new to teaching according to the college and career readiness standards, now that they've been around a while, there are a lot of materials out there that have already been created. But it can be hard to know, like, what does that look like in class? If that's not the way that I was taught or it's not the way I've taught before, what does that actually look like? Are my students going to be willing to struggle with a problem? Are, if I ask them a question that's open-ended and have multiple answers, are they gonna, how's that gonna look? How am I gonna respond if somebody gives me a wrong answer? How am I gonna figure out if somebody explains how they solve something and I've never thought of it that way? So I think it is helpful to have either in a professional development setting or to see a video, but to actually see what that looks like in action. So is 60 the total that you started with?
Yeah.
Okay, and then you did the crossing out method?
Yeah.
Okay.
So I only have these left.
All right, so then that's your other group, right?
Yeah.
When you're subtracting, you've got those 2 different parts.
Yeah.
Okay, good. So then see if you can find one more way to solve that same one. So which problem was this? Was this the first one or the second one?
The first one.
The 49?
Mm-hmm.
Okay. So you've got, you have 60, so there's 5, 10, 15.
10, 15, 20, 25.
So 25, 25. And then, so I think you might have a few extra. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So that's 22. 10, 10, 10. So there's 40. So there's 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you do have 60. Yeah. Okay, so you have 60 and you removed 49.
Okay, so what I did. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49.
Okay.
This is 49.
That's 49. So that's one group that you've made. Okay. How much in the other group?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
I don't think you counted this one. Let's check. 1.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
11. Okay, so you have a group of 49 and a group of 11. So what I meant by putting them back together.
So I just do something like this.
Exactly. Putting back together, you can use
And then
addition.
That's 10. That's 60.
Yep. And because they go back together and give you 60, it's a way of checking that you did the subtraction right. Okay? So you separated and you put them back together. Okay? All right, so folks, I'm going to have some volunteers so we can share some different ways that you solve these. Jahira, which one do you want?
Number 1?
The first one?
Yeah.
Okay. How did you solve it?
So I did 60
Mm-hmm.
minus 49.
Did you do it on paper?
Uh-huh.
Okay.
60 minus 49.
Okay.
So 0 bar 1 from 6.
Okay.
Yeah.
So you had to break up one of these tens.
Yep.
Okay.
Then 10 minus 9 is 1. And then 5 minus 4.
Okay. All right. Great. Did anyone have another way to solve the first one?
49
Mm-hmm.
plus 10 is going to be 60.
So you're really
I mean,
close.
10. No, 11.
Okay, so you added 11.
Yeah.
Let's try that. 49 plus 11. Okay. 9 and 1.
And 6.
6. Okay. Good. So we had one version of subtracting using that borrowing or regrouping. Adding. Now, did you add to check what you already did, or was this how you solved it? By adding up?
I check it, make sure it go back to 60.
Okay, so you use this to check after you did it the first way.
Yeah.
Okay. Any other ways that people solve this?
Wait, what did she do? What did you do?
So
Or hold on, Jean, we'll get you in 1 second. Yeah, go ahead, Shonda.
There, you lost my train of thoughts.
I'm like, what she added? Like, no, she just like added. She added 49 and then she added 11 to come out with the 60. That's what she did.
Oh,
Yeah, thank you, help me out. I lost my train of thoughts.
okay.
Like that.
And I
You
did the
understand,
number
right?
line. Yeah.
Mm-hmm.
And I did the number line for 61 and 49. 61 take away 49. Did she just do that?
She did this one.
I did the first. She did the first one. I did the
Okay.
to add it together.
Mm-hmm. The same one. I
The
did.
same the first one.
So I want to hear about the number line. I also know Jean wanted
Oh,
to
he
share an
did.
answer. So
Yeah, 'cause
Jean, were you talking about the first one?
Yes.
Okay, how did you solve the first one?
The first one, you pose 60 minus 49.
Mhm.
So, did you pose it, please?
What
you
do
pose it? You compose it?
Oh, sure. So did you write it, did you use paper?
Yes.
You wrote it on paper?
Yes.
Okay. And how did you solve it?
So 9 to 10, 1?
Did you do like a similar like regrouping strategy?
No.
No?
So I have to take, this is, I know this is 10.
This
So-
is 10?
Mm-hmm.
Okay.
And 10, you take away 9.
Mhm.
It is 1.
Okay.
So, and the 6,
Mhm.
take away 4.
Mhm.
This is of 3,
So you're doing 6
6.
tens
Take
minus
out
4 tens.
Take out 4.
Mhm.
6 take out 4.
Mhm.
So, of 3.
Well, if you're doing 6 take out 4, you would get 2.
3. We get 2.
Yeah. Show me how you're thinking about it. 'Cause
Like
I'm
you
not sure I'm
do
following.
16,
Mm-hmm.
49, the 10, take out 9, it is 1,
Mm-hmm.
okay, so 6, take, well, you have 6, and then taking 4 out, 1, 2, 3, 4, 5, 6, and then 2.
Okay. So it looks like you got a different result for the first one.
Mm-hmm.
Okay. How could we check to see if yours is correct?
We're gonna plus it 60 to 21.
Okay. So you want to add to check
Yeah,
it?
Yes.
Okay. Okay, so tell me what you're adding back together.
6, 7, 8, no. Okay. 60 plus 49.
Okay.
Mm-hmm. Now. Of 9.
So you're adding these, right?
Yes.
Am I following what you're saying? Okay, so you're adding that.
9,
Mm-hmm.
6, 7, 8, 9, 10.
Okay. Does that tell you, so you added it correctly. Oh, does that tell us anything about the original problem?
Mm-hmm.
Like, does that tell you if it checks out?
Oh. I used to check it out like this, but I don't think the answer is good.
So I have an idea. I saw some people also did like a visual version. Ooh, I've got a nice one over here. Let's see if we can match that picture to some of the different math that was done. Okay, because we got a couple different things going on. Some of them match what we're doing, and some of them have created a different problem. So is this for the first one or for a different one?
For this one, for the second one.
Okay. So you have a picture where you have 60 and you colored in 58.
Mm-hmm.
Okay. So I'm going to reproduce some version of that up here. It won't be as pretty as yours, but give us the right idea. All right, so actually, let me get a better whiteboard to do that. So I have more space. So instead of doing really nice squares like you did, I'm going to do dots, but ooh, that's big. 6, 7, 8, 9, 10. There's no rule about how to draw your dots, but I tend to do groups of 10 so that if I lose count, I can go back and say, okay, I already did 10, 20, 30, 40, 50, 6, 7, 8, 9, 10. Yeah, I think you all also had yours in groups of 10, is that right? Okay. And then it looks like you colored them in. This was, oops, hold on, fix that. This was 60 minus
58.
58. Okay. Would it be okay if I switch this so we use the same picture to do 60 minus 49, which was the first one? And then we'll go back to the 58.
Okay.
Okay? So how could we use your picture to demonstrate that first one?
What you do is like you color 49 minus 11 dots.
Okay?
Yep.
So I can do, since I have these in groups of 10, I can do 1, 2, 3, 4, 40.
Yep.
And then I need another 9. All right. So I didn't color them a different color. I just circled them, but it kind of matches the idea of what you were doing. And I know other people do this as well. So in the circled group, that's our 49. All right. So what does this group mean, the ones that are outside?
Is that how many is in the left?
Yeah.
Is the answer pretty much? Yeah.
Yeah, exactly. Right? So when we were solving this, right, we've been talking about how subtraction we can think of as breaking into groups. So we had a 60 total, but we broke it into a group of 49 and 11. Now, a lot of folks were talking about adding. When we're adding, that's always combining groups to make a whole. So these are the parts that we can combine back, right? So which numbers would we be adding if we wanted to check it that way?
60. We added 11 to make it come out equal 60
Okay, what did you add 11 to? Just wanna
to the
make sure.
49.
To the 49. Okay, so we're adding this group and this group, those two smaller parts back together to see if they do give us that total of 60.
That'd be 10.
5, 6. And it does check out. Okay. If we wanted to, we could count them all up again, but we know that there's 60 because we already counted them. But that's why the addition works, because we broke it into groups, we can put it back together. Okay. If I was going to add, we had another equation on the other board that was done correctly. That was one of the suggestions. And it is a correct addition equation. But it doesn't actually match the picture that we have here. Because the 49 is part of the 60. If we added them together, we'd be getting lots more dots, right? Which is true, but it doesn't actually tell us about the subtraction situation. Does that make sense? Right. You did it correctly, but it doesn't match this. Okay? It doesn't let me erase. Okay, nice. You mentioned you used a number line
Yeah. I'm
for one
still
of them. Do you
trying
mind
to-
talking
yeah,
about that?
I'm still trying to, use the number line. So I did the 61 take away 49, and I came out with the answer 12.
Okay. How'd you use
And
a
I
number line for that?
started from 49 all the way up to 60.
Okay. So make sure I'm reproducing it correctly. You started at the 49? And then you
then,
wrote the
yeah.
numbers down? 4, 55, 56, 57, 50.
It is. I'm still trying to do it without writing all of it, but I'm still.
Okay.
As long as Coma is the same way. We learn differently.
But this is neat because this is like you're exploring how to make sense of this strategy, right? And you may find ways to do it faster later.
But
Yeah. So how did you, once you did that, how did you count to see like,
I counted 49 to. Yeah.
did you
Well,
count each
actually-
number or did you count steps?
Well, see, that's where I did count each number, which was 49, 50, and then I'm like, I believe I'm supposed to start from 50 and 51. So I just kept coming up with 11 and 12.
Okay, so that's really interesting. Let's talk about that for a sec, because that, and I'm glad you brought that up, because that's what gets challenging with this strategy. Although we've seen that the counting up can be a really useful strategy. But there is that question of like, do I count every number, including the first number? Right? So in order to answer that, I want to go back to that idea of the picture that we drew. I'm not going to draw all the dots.
Oh, 61.
Right?
I counted
But
up to
yeah, yours is 61.
Oh, I counted
So it's
all
going to
up
have more. But
60. Okay.
basically, when we're counting up, we already have a group
Yeah.
of 49. We already have that as one group. So when we're counting the things in the other group, we're not going to count the number 49 because that we've already counted. That's already part of that first group. We're counting everything that comes after. Because 50 means, okay, there's one more dot. Now there's 50, so that's 1, right? 51, 52, 53, 54, right? So you were right, you do start counting on the 50, but that's why. Because when we broke up those dots, all 49 were already in one group. So that's why we start counting with the next one. 50, 50, 51, 52,
Right,
53,
yes.
54, 55, 56, 57, 58, 59. There's 10, 60, 61, 12.
Okay.
But I'm so glad you brought that up because that is one of the most common things that we do with number lines is we think about, wait, where do I start? Do I start at the beginning or do I start with the first step,
Right.
right? And in this case, it's the first step because it's the next one. Did anyone use a counting up strategy, or we can try it right now for this one?
You could do the 100 chart
You could use the hundreds chart,
and get the answer.
okay? We could also do the counting up with the hundreds chart too, like.
Right.
So where are the numbers that we would need if we were going to use this to help us count up?
You already has 60 right here.
Mhm.
Then you go 58. It's right here, but take it away.
So how many are in between them?
Right here.
Yep. Kind of like your number line
Yeah.
that you made, because it's already
So-
written for us.
Right.
So how do we use that to help us answer the question? Sorry, you guys can see. We got 58 here and 60.
So what count? You said count from the back, right?
All you just kept
Well,
one.
we could count back 58, although that is going to take a while. But we
Yeah.
could do that. We could count 1, 2, 3, 4, 5, right? But I was thinking more of the method you were using, where you were counting up. So if you already have 58 in that first group,
It's more to.
right,
that
you
number
need
to go back. Yeah.
exactly. How many more do you need? Well, you're already at 58. 59, 60.
So it's closer to come forward, further than go back.
Right.
Yeah.
It would work either way.
Yeah.
But in this case, you're only missing
One,
2
two
because we got 58 already, so it's 1, 2 more.
more.
Okay.
Okay.
We could count back, right? But the problem is if I have to count back 58, I'm just more likely to make a mistake because it's so many. I would land on 2 if I counted back. Because you could do it that way. You could do it
But
that way.
that's, let me take a little bit. Okay.
But when you have numbers that are really close together,
It's
it means
better
you're
to-
only missing a few.
Okay.
Right? Let me see if I can just do a quick visual of that. And then we're going to start our next activity because I think my dots are still here. Okay? So here's my 60 dots. I'm going to get rid of the green stuff. Doo-doo-doo.
What number were we doing?
There we go. All
I
right.
think this one
60 and 58.
60
and
minus
58.
58. Yeah.
58. Right? 58 is almost all of the dots.
That's be 2.
Right? How much are we missing? Well, if we were counting them, that's 58, 59, 60. There's just 2 in the other group. So if we were going to put them back together, what are the 2 parts?
The 58
Mhm.
and the 2.
And the 2. Right? And that's what our counting up method is really trying to do. It's trying to say what's missing to get the rest of that 60. What's missing? Well, we're missing those 2.
Okay.
So it's really similar to what you were doing, and I'm glad you're experimenting with that because for some problems that can be a quick solution, and for other problems, other methods are quicker. But we want to understand it first, and then it'll speed up later.
Okay.
Did anyone else have anything they wanted to share about the warm-up?
No.
Okay.
I could, no mind.
What?
Because I would say you could do money way how you spend it. Like if you do 60, if you had 61 already and you spend 58 and you got 2 left, that's goodbye.
Well, you brought up a really interesting point. Do you notice that some of these are closely related?
Related money.
So this is the one we just solved, right? So how are you thinking of this one in terms of money?
Because if I already had 60 already and I spend 58 and on it I had left is $2.
Okay. So Shonda, what if we change that situation just the teeniest bit? You're still going to spend $58, but this time you had 61 to start with.
All right.
You can ask folks to help you out too, but I want to see how does that change it if I give you $1 extra at the beginning?
If oh, sorry.
Go ahead. No. Go ahead. You was on a roll there. You just made me look at it differently. So just by the way you was doing it.
So if you change it, will you change it? 61?
So you're still going to spend $58, but instead of starting with $60, I'm giving you $1 extra. You're going to start with 61.
So that's gonna be probably 3.
You're gonna have a little bit more than the last time. It's like
You went up a little bit more.
Yeah.
If I gave you an extra $1 to start with, that extra $1 is still there at the end, right? Because you spent the same amount. And we could also check it with the addition, right? We start at 58, 59, 60, 61. There's 3. So sometimes we've seen these are designed so one is similar to another. And we've been looking at things where, we're trying to explore what happens when we change that first number. How does it change the result? What happens if we spend more money? How does that change the result, right? So that's what these are looking at as well. Okay. All right, so we're going to do something a little different today. We are going to be looking at some strategies for adding up a whole bunch of amounts. What you're going to get, there's a jar with a whole bunch of different amounts of money in it. And your goal is to find the total of all the money. But to help you out, inside the envelope, you've got all the little amounts. So you're going to want to look for ways that you can group those amounts together to help you get a total. Does that make sense? You're going to look for combinations of amounts that make $1 to help you add up the total. Does that make sense? Okay. Do you guys all want to work with one set, or do you want 2 sets
We worked
of the same thing?
Same thing.
Okay. And you guys can all share one set if you want. There should be, I think, on this one,
Cause they are my 2
there should
brains.
be 12 amounts. I'm going to give you guys the same set. Okay. So you're trying to come up with the total for all of these 12 amounts. But to help you do that, you're going to look for money amounts that you can put together to make $1.
I'm trying to make.
Does that make sense? Look for amounts that go together to make $1. Yeah. And you'll see that the cents are written in 2 different ways, and I think most people are familiar with this, but sometimes you'll see cents written with this number or this symbol, like that, and sometimes you'll see it as with the dollar symbol and the decimal point. But they're all cents.
Is it all the same numbers in here? Because I
You
need
have to
to.
match it.
Can you see it? So all of these numbers are the ones that are here, and you're trying to find the total.
I want my own. I can't see
Sure,
that.
I got more. Just try not to mix the 2 sets so you don't end up with extra money in one, okay? So this has got the same as this.
Okay.
But you're looking for numbers you can group together to make $1.
You got what you're saying?
Does that make sense?
You know I'm
You
confused.
just in space.
What you do, right? Take
That's
the,
why I need
you
y'all
see,
say-
like it say 50 cents there, and then get to a number that match the 50 cents.
Even write
So,
it down. If it,
Maybe
Yeah.
this and this.
So we can put like a puzzle.
Kind of. So for example, if you have 50 cents, how much more do you need to make $1?
50 cents. Then
That's
you
only
added it.
one.
Okay, so if you need another 50 cents, then these 2 together, that's $1. So you're trying to like group things together that will make $1. So this becomes $1. Would it be helpful to use some of the money?
I guess so.
That's up to you. Or another thing, because we're working, a lot of these are working with tens, right? So in this case, like you've got the 50 cents is 5 tens. And then another 50 cents, you need 5 more tens.
Tens.
And then that makes $1 because it's 10 tens.
So if I put 75 cents,
Mhm.
that'd make $1.
How much more would you need to make $1 if you had 75 cents?
75 cents.
Mhm.
50 cents. No, 25 cents.
Okay. Yeah, so this is like 3/4 and 1/4. You put those together, that's $1. So now you have another pair that makes $1.
$1.
Okay? So that's what you're trying to do with all of these, is match them up. so that they make $1.
Then
And if you want, you can use any of the tools that you normally use, okay? Or you can, you can write it on paper too. All right, I'm gonna go around and check on the other groups and I'll come back. I always want students to be able to practice explaining their thinking in a lot of ways, and to be able to either show or, articulate like how they approach something, and then to be able to listen to each other, because part of it is also learning to like follow somebody else's train of thought. So I think that's really important too. So show me some of the things that make $1.
I said 10, 20, 30, 40, 50, 60, 70, 80, 90.
Okay. So you kind of made like a number line out of it.
Yeah.
Okay. So that makes a nice number line that jumps by 10 cents. Your goal is we want to add up all the amounts together. Okay?
Now this is $1.
So what you're going to want to do, each one of these represents like this amount of money, right? So I saw before you guys had put 50 cents and 50 cents, like that's $1, right? Are there any other like pairs where you put those amounts together and you get $1?
She's my math teacher, and I respect her. And she's someone that can help me do my math, and she's a good teacher to have. I could do something like this, Melissa.
Okay, well, let's see how much money is that. So if you have 20 cents and 25 cents, and if you need to, you can write it down to figure out how much that is. But does that make sense what you're trying to do? You're trying to make $1. So like this is $1,
Yeah, this is
right?
$1.
But you want to find others that you can put together to make $1.
I don't think I have. Group can make me $1 on this.
Can you see them?
Okay.
You can rearrange them. You can match any of them, but you're trying to make $1.
Okay.
So like this would be 75 cents.
75.
Sometimes they use a different symbol for cents. This symbol also means cents, so that means 70 cents.
so with 60.
That means 90 cents.
And this one.
So for example, if you have 90 cents, how much more do you need to have $1?
10 cents?
Only 10 cents more, and then you'd have $1. So look to see if you have one that is 10 cents. There you go. All right. So that's another pair. So that's another $1. Okay? So that's what you're looking for. Making pairs that when you put them together make $1. Now, how would you check that? Could I borrow a pencil for a second?
This one?
Anyone? Yeah, it's fine. Because Lonnie, I know you feel very comfortable often with when things are lined up. So let's check and make sure that that's true, right? If we have 90 cents and 10 cents,
This is 0, and that's 10.
right? And 100 cents is $1.
Did I do that right?
Okay, so that checks out. Just like the other one, when you have 50 cents and 50 cents, it's still going to make $1. Okay, so you can use this if that helps you to check them, but you're looking for more pairs that are going to do that and make $1.
So I could do 7. This one?
This is 75 cents
Cents.
and 25
25
cents.
5, 0, 7, and that'd be 1,
Because you made a 10. Yep, so 110.
8, 10.
Mhm.
Another 0.
So this also makes $1. So far you have $1, $1. Okay.
Oh, I didn't do that.
Which other ones did you already check? You did this one, so you know that's $1. And 60, 40. So let's put those together. That's $1. Okay. So these are the ones you have left to.
I didn't do this
Oh,
one.
okay. You can check that one too. Let me give folks a couple more minutes to see how many of those pairs you can find. and then we'll share them and see if people found the same groups.
It's 60.
So you added that correctly, but we haven't found a dollar yet,
Yeah, I know that.
right? Yeah, but that's correct. So this might help if we think about a lot of these are groups of 10, right? There's things like 10 cents, 20 cents. A lot of them are using tens. So I'm going to represent those tens with dimes because these are 10 cents. So how many dimes does it take to make a dollar? 20, 30, 40, 50, 60, 70, 80, 90. Well, that's 90. And then if I add 10 more cents, that gets me to a dollar. Yep, so that's a dollar right there. So 10 dimes or 10 groups of 10, that makes a dollar. Because $1 is 100 cents, 100
Can you
pennies.
do it with quarters too?
We could, yep. The reason I did dimes for this was because a lot of these are like tens. They're like amounts that you could make with dimes. So I wanted to show you how some of the ones you found, like what that looks like. So like 50 cents and 50 cents. What that looks like is you've got 50 cents here, 50 cents here, right? And together, those make the dollar. Okay. So we know that one works. Well, what if we're trying to do this one, for example, 70 cents? So 70 cents, yep. So I want you to just make 70 cents in a group. Like you count out, yeah, like 10. 70. So this is 70 cents. And this is the rest of the dollar. So how much is over here?
70?
So this one is 70 right here? Right? 70? How much is over here?
30?
30.
Exactly. We got 30 left. Okay. So this 30 and this 70, that makes our dollar. Okay, because we had 7 over here and 3 over here. So now you have another pair. Okay. Pick another one and try the same thing.
40.
So 40. So let's make a group of 40 cents.
40.
So that's this group over here. Now how much left do you need to make that dollar?
20, 30, 40, 50, 60.
There you go. So now you have another way to make a dollar, the 40 and the 60. So there's another pair. Okay. This one is going to be hard to make with the dimes, so let's do that one at the end. Mhm.
10, 20, 30, 40, 50, 60, 70, 80.
So how much more do you need? Good, yeah, 80 and 20, so there's another dollar. All right. What do we have left? Those ones will use quarters. Let's do the ones that use the tens.
90. 10, 20, 30, 40, 50, 60, 70, 80, 90.
Okay, what's missing?
1.
1 dime, yep, 10 cents. So the 90 and the 10, there's another dollar. Okay, so each one of these is a group that makes a dollar. And then what do you have left there?
95.
So this one, because these go by tens, you're not going to be able to make that with just those. Are you comfortable counting with quarters? Okay, so maybe do that one, count with quarters.
25, 30, 35, 40.
So each of these this is a dollar, right? Each of these is 25. So you got 25 here.
This one is 75.
So this with 2 of them
It's 50.
is 50, right? So right now you have 50 and 50. If I put another 25, this is 75 and 25. And together they make $1. How many dollars were in that whole group?
2, 3, 4, 5, 6.
Okay. So one of the things that we did was by grouping them, to put them all together was really quick. Like once you had them grouped, you just had to count them, right? The hard part was just grouping them together. But once we do that, then it makes it very quick to get the total of everything. So that's what we've been working on trying to do. Okay? So what I'd like you to do in your notebook is to write down the combinations that we made that made $1. Okay, and then we're going to share those in a minute.
Because it's easier for me to like, do it like that. Yeah.
Yeah, cause you I was confused, but now I'm confused.
Again? Okay.
No,
Now you're unconfused?
No, no.
Wait.
At first I was
Okay.
confused, but now I'm not confused no more.
Okay. Oh, it looks
So-
like you found a lot of combinations.
Yeah, I had to did it, and when the lady to help me out, how to explain how to do it.
So what I want to do is I want to physically pair up all of these numbers that you just checked, right?
Right.
Okay. How many dollars? Each of these makes $1, right?
Mm-hmm. How many? 1, 2, 3, 4, 5, 6.
6. Okay. All right. So what I want to do up here is I want to look together at how we group them, but also why we would even do this. So the specific goal in this lesson was that I wanted them to see that they could look for pairs of numbers. We've been doing a lot with money. So I wanted them to be able to look for pairs of numbers that make $1, and to also see how much easier a calculation could be when that occurs, so that it's, you know, it's worth sometimes looking for those things rather than just plowing through and adding in order, but that you could actually simplify things for yourself if you can find those groupings that make friendly numbers. So that was the goal, and also for them to then connect that back to the other things they learned about the commutative property and the associative property. Even though with this particular level, I haven't spent a lot of time teaching them those specific vocabulary, I wanted them to be able to, you know, express it in their own words, which I think some of the students did in class, did a good job saying, you know, you can skip over the numbers, you can do it in different orders. Like, that's the idea I want them to have. You all had the same jar of money. Can you give me some of the combinations that made $1?
40 plus 60.
So 40 cents plus 60 cents was $1, right? Now what I'm going to do, because I don't have them physically up here, is that I'm going to actually just cross these out, because our goal is we want to find all, like, how much is the total of the money in the jar. So once I've counted it, I don't want to count it again. Okay? So 60 and 40 make $1, and I cross those out. Okay? Can you give me another example?
90 cents
90 cents
to 10 cents.
and 10 cents
You make $1.
make $1. Okay, great. And I'm going to cross those off here so I don't count them again. Okay, Jean, go ahead. 50 cents
2 50 cents,
and another 50 cents. 2 50 cents, yep,
so I get $1.
is another $1. Great.
75 cents,
Okay.
25 cents
And 25 cents, yeah,
is $1.
is $1. Okay, so let me make sure I cross those out. We got that one and that one.
Yeah, I'm a little confused. Okay, so I did 10 cent, 20 cent, 30 cent, 40 cent,
That will also make $1.
which is $1.
Yeah, there are other ways to group this.
Okay.
Yeah. This particular activity, this doesn't always happen in real life, that they all match up. And so you may have to put a couple things together to make $1. So that can be a really good strategy too. if I was going to put those together, I would just write it over here because you used some that I wouldn't want to use twice.
Okay.
Because our goal is just to count up all the money, ultimately, right? Yeah, because this activity came from a math class, they did make all the amounts pair up to make $1. But I like that you were looking for other combinations too.
I did do 80 cent plus 20.
So that's another one that works out really nicely. Okay. And it leaves us with just 2 left, 70 cents
Plus 30.
and 30, which is, again, another $1. Oh, they wrote it differently, but you can write 70 cents either way. All right, so why did we do this? Why did we group it and make dollars? Because I wanted to find the total. I could have just started at the beginning and went 50 cents plus 60 cents plus 80 cents plus 75, right? That would work. Okay. This will work, but does anyone want to do this? I mean, this looks kind of.
It's gonna take a long time.
This could get tricky, right? I could do it, but it would take a while, right? We could have also grouped them in different ways that don't add to $1. Yeah, go ahead, Chanda.
The same thing we did there like a couple months ago, and how we had the little story, and we added all together, and it would take a long time. And another guy was split it up, and then come with the same answer. They split up in 3 ways, and so I had to add all of them together, and then they go to the same answer of the number.
It is exactly like that story that you're talking about.
Yeah.
So that activity, if you guys were here for that, where we looked at different people saying, like, here's how I added up these 4 numbers. And one of the examples was a guy who grouped them.
Group of 3.
I'm trying to pick, like, what are the specific math terms that are going to help them the most at that level. And usually it's after we've, like, explored a concept, and then we'll, like, give a name to it. And while we're exploring the concept, I want to encourage them to put things in their own words so that they can really, process it, paraphrase it, and then eventually we might come to say, okay, this is what we were doing. So, for example, when we were doing rounding, we were talking a lot about what number is this in between. And we talked about what that meant. And then we said, well, what number is it closer to? And what does it mean to be close to a number or not close to a number? And once they got used to that process, then I said, okay, what we're doing right now is we're rounding to the nearest dollar. Like, that's what it's called mathematically. But I kind of gave them that at the end. Yeah, so now that we've grouped all of these, how much money is in the jar?
$1.
Yes, $6, right? Once we've grouped into these dollars, now $1 is a really easy amount to count up. 1, 2, 3, 4, 5, 6. So that last final addition actually becomes much simpler because we created these, sometimes they're called friendly numbers. We created friendly numbers that are really easy to add. $1 is a very friendly number, right? It's easy to count up one by one. What are some other numbers that are easy to count by?
The next number that come after.
No, I mean, if you're counting groups of things, like, I mean, most of us, it's easy to count 1, 2, 3, 4, 5, right? If you were counting money,
2 by 2.
you could count, you could count put 2 by 2, right? 2, 4, 6, 8, 10.
The jumps thing, and you get the answer.
Yep. So some numbers are easier to jump by and some numbers are not, right? Like, people tend to really like 5s. 5, 10, 15, 20. People often don't like 7s because they're not as regular. They don't have a nice pattern.
And then you have to.
You have to remember more. Yeah.
Too
So we
much.
could count by 7s, 7, 14, 21, but it's not as friendly. It's not as
No.
easy. Another number people really like a lot of times, that's why I came over here, are tens, right? 10 is often a very friendly number because we count by tens a lot. 10, 20, 30, 40. So when we can group things in tens, even like the first activity where I was drawing dots, a lot of people draw them in groups of 10.
Even 20. So
20 is not bad either, right? If you got $20 bills, 20, 40, 60.
Yeah.
Numbers that are easy to count by make good friendly numbers. Because once you have those, then you can count them up. Yeah, go ahead.
I was saying, like coins, they make like $1, and you have to count it up, or something like that.
Has anyone ever had to like count up a lot of change, like a lot of coins?
Yeah.
How do you do that?
I do it like usually like when if I gonna do like $1 and 1 cent, I do it by group like 5, 10, 15, 20.
So you count like
Yeah.
5 cents at a time?
Yep.
And then do you just keep counting until you get to the end, or do you make piles, or like
I make pie.
how much do you put in a pile?
50.
50 cents? Okay, so you count 50 cents, and you make another 50
50
cents,
and
and
another
another 50
50, yeah.
cents. Okay. You could do it with nickels. Yeah, you could do it with nickels, right? So you could count the nickels 5, 10, 15, 20. And a lot of times what will happen is when people get to $1, they make a pile. And then they count another $1. And they count another $1. Because if you got a ton of nickels, you're probably going to lose count at some point. But if you've made piles of a certain size, like $1, then you don't have to start over. You just go, oh, okay, this was $3. Now here's where I left off. Yeah. So we do this for a lot of things. We try to group them into groups that are a friendly size. $1 is a friendly size, okay? So we just looked at this in a situation where we were thinking of it as like a jar of money, all these different amounts of money that we were trying to put together. What we just did here can work for any numbers that we're working with. So what I'm going to give you now, we're going to look at the top one. It's a long addition equation.
So I do the same thing I did here.
So what we're going to look at is how can we use the activity we just did to make a long addition equation like this a lot easier to solve. Okay, so we can look at this together. So I want you to take a look at the top one. We've been working on estimation and number sense, especially around addition and subtraction. And so some of the big ideas in that unit are the idea that numbers are commutative in addition, that you can change the order, and also associative, that you can change groupings and you'll still get the same result. So they have had other experiences with that. This was the first time we were explicitly talking about like choosing groupings to be strategic. Not just so you don't have to add them all at once, but so that you could actually pick numbers to add if you notice that they make a friendly number. And we have been talking a lot in this unit about like making calculations easier. We also did a couple of lessons about rounding and how rounding, like the idea is that we can make the number easier to work with if we don't need an exact number. So this is sort of pulling together some of those themes we've been working on, but what I was hoping that they would see was that if they can recognize certain pairs, especially things that make $1, that was the focus today. I think the students got the idea of grouping, but I did think that they are probably going to need more practice to get comfortable with looking for pairs that make $1. So there are a couple other activities I plan to do with that, but I'm also thinking I might add some like a game or something that might reinforce that idea of like how do we find those pairs, get them more comfortable with common pairs that make $1, which also map over onto pairs that make 100, which is another part of this. So what we have here in this top one, I'm going to clear this for a second. We've got an addition equation with 1, 2, 3, 4, 5, 6, 7, 8 different amounts of money. Now, we could just start at the beginning and keep adding, right? That's always an option. But what we've been looking at is that sometimes there's ways that we can change the order of things or group them together to make that addition easier. Do you see any amounts that would group together, like the ones that we just did in the jar? Yeah, Shonda, what do
We
you see?
could do 10 cents to 20.
We could do that. We could.
And group that.
And how much would that make if you were going to add those? You can do it on paper if you want. I'm looking for my pen. Here we go.
3
3
dollars.
groups of 10.
Yeah,
So it'd actually be 30 cents.
30 cents.
Okay. 30 cents isn't bad as a number.
Right.
But one of the things we were just looking at is when we can make dollars, dollars are really friendly to add up. Are there any of these amounts in here where you could put two of them together to make $1?
Yeah.
Yeah.
What do you see, Jahira?
I see 80
Uh-huh.
plus 20.
Okay. So they don't have to be near each other. They can be far away. Right? 80 and 20. Those were two of the little amounts from the jar that we put together because 80 cents and 20 cents makes $1. So that's $1 right there. Okay. Are there any other amounts that we can put together?
70 and 30.
70 and 30. Okay, I'm going to use a different color just so I don't get mixed up. So I can put the 70 and the 30 together. And now I have another dollar. And the 60 and the 40. Nice. Okay, let me get a different color. So the 60 and the 40, that makes another $1. Okay. And then the far away ones, the 90 and the 10. Yep. 90 and 10 makes $1. Okay. How much money is that all together?
$4.
4. Yeah, $4. Now that we've grouped them into dollars, putting those all together is much easier because we just go 1, 2, 3, 4, $4. Now, it's not always going to work out as perfectly like this, right? This is like a rainbow, literally. It all matched up really nicely. But what we want to start to do is we want to start to look for these kind of pairs of numbers that make these really friendly amounts. Because whenever we can do that, we're going to save ourselves some work at the end. We won't have to add amounts that give us irregular numbers. We've got these nice friendly numbers. Okay. So there's a couple things about addition that allow us to do this. We've been talking a lot about addition in this unit. Why is it okay for me to do this? Because I just added the first number and the last number.
You can skip around and
Okay.
try and get that dollar.
So with
You don't have-
addition, you can skip around?
Yeah, you don't have to go in order because you see it like that.
You don't have to go in order, right. That gives us a lot of flexibility. I'm not required to add them in the order that they were given to me.
And sometimes you just want to go like the easy way. You don't want to use your mind to that level, you know, to get complicated.
Right.
Yeah.
That's a lot of what we've been doing in this unit. How do we make the math easier?
Mm-hmm.
We
Right.
can break it down.
And by breaking it down, by looking for certain strategies, we make it easier. And when we make it easier, we're also more likely to be accurate, too.
Correct.
Because when we
Yeah.
make it harder, then it's easier to make a mistake. When you make it easier, you know, your brain's less likely to lose something.
That's working, yeah.
Okay? So this is a really important idea about addition, that we can skip around. We don't have to add an order. Okay? And I also want to point out the thing Shonda brought up earlier. She said, remember that conversation and that example where the guy put things in groups, right? That's what we're doing here too. Not only are we mixing up the order, but we're putting them in little piles. We're putting the amounts in little groups, and then we're adding up the groups. And sometimes that's a really useful strategy for addition. We can put the numbers, or I should say add the numbers in groups. We can add the numbers in groups. Okay? And what we saw here is sometimes groups give us friendly numbers. We can look for friendly numbers.
I like school. I like the teacher. The teacher pushed me more, to learn more, to help myself. Sometimes he gave me hard to what to do. And then sometimes I don't stand there, I say, I don't stand this. And then sit down with me, explain me how to do it. You know, the thing I'm stand, I can do it fast. But sometimes you don't stand your things, you know, it take your time to figure out.
Well, I do this work because I really enjoy it. Honestly, I feel like I'm very lucky that I get to do something that, you know, I find intellectually interesting. I find it personally satisfying. I've always liked math, but teaching in this way also, it's exciting for me because I think, man, I would have loved this. Like when I was younger, I would have really, really loved this. And so I like to both have the opportunity to like do these things and do them with other people and to see other adults get to have that experience.
I just want to go to college, so my daughter and I went to college, so now I want to go there where they been. They like for me to be in school because they want me to do better and graduate.
I mean, I think what's the most rewarding for me is kind of to help shift people's beliefs and perceptions about like what math is and how it is related to them. Because for so many adults, math is something, you know, they did in school. A lot of times it's seen as a gatekeeper or a hurdle that they have to get over. You know, I gotta pass this test. I gotta pass this test. That's often having more experiences with this kind of problem solving and like quantitative reasoning can really like be useful to them, can help them both do the things they're already doing and feel more confident with it and maybe even venture out into things they haven't done. I very much respect my students' goals, and if their goal is the test, I want to prepare them for that, but that's not enough for me. Like I want it to be a lot more. And so part of it is I also want them to see that this can be valuable to them on multiple levels.